everyone! Welcome to my math class. Today, we will learn about patterns and sequence. Let's start with the word pattern. Patterns refer to the usual types of procedure or rules that can be followed. It can be numbers, shapes, or objects that are arranged according to a rule. Patterns are useful to predict what came before or what might come after a set of numbers that are arranged in a particular order. Look at the example. In this figure, we start at 1 dot and follow by 3 dots. Next is 6 dots and then 10 dots. Now, if we want to know the next number of dots, we can easily answer that because in this figure, it has a pattern. The next example is the set of numbers 2, 3, 5, 8, 12. Let's see if this example has a pattern. Now, we will determine the gap of each term. From 2 to 3, there is a gap of 1. And from 3 to 5, there is a gap of 2. From 5 to 8, the gap is 3. And from 8 to 12, the gap is 4. As we observe the red numbers, there is a pattern for this set of numbers. Then, we can say that this is an example of pattern. Sequence is a set of values that follow a particular order. It can be finite or infinite. Finite sequence, if we count the number of elements in a sequence, and infinite sequence if we cannot count the number of elements in the sequence. Take note that a sequence is the follower of the rule, and the rule that I am talking about is the pattern. For example, this set of number 3, 6, 9, 12, and 15. The pattern is we're going to add 3. For the first value, we have 3 plus 3, we got 6. Then 6 plus 3, we got 9. 9 plus 3 is 12. And 12 plus 3 is 15. The pattern is by adding 3. The sequence here is 3, 6, 9, 12, and 15. And the pattern here is by adding 3. This type of sequence is finite because we can count the number of elements here. It has an end term which is 15. Another example is the sequence 2, 4, 8, 16, 32. The pattern here is by multiplying by 2. Starting from the first value, which is 2, 2 times 2 is 4. Then 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. Take note that there is an ellipsis symbol. In this sequence, it means that there are more elements after 32. And we cannot count how many elements are there. Therefore, this sequence is an infinite sequence. Another example of sequence is 5, 10, 15, 20, up to 100. There is a symbol of ellipsis here, but there is an end term. Therefore, we can consider this sequence as a finite sequence. Next is term. Term refers to each value in a sequence. For example, in the sequence 5, 6, 7, 8, 9, the first term is 5. The second term is 6. The third term is 7. The fourth term is 8, and so on. To get the end term of this sequence, we will be using the expression n plus 4, where n is a positive integer. When we say positive integer, it is also known as counting numbers or natural numbers. Now, for example, we want to know the 105th term of the sequence. We will not use the listing method. We will not list all the numbers to find the 105th term. We will use the n plus 4 or the general term in order to get the 105th term. Using the n plus 4, we will substitute n by 105 because we want to know the 105th term. So, n plus 4 becomes 105 plus 4, which is equal to 109. Therefore, the 105th term is equal to 109. The last term you will need to be familiar with in this lesson is series. Series is the sum of the terms in a sequence. For example, the given sequence is 5, 6, 7, 8, 9, and you will get the series. Just get the sum of all the terms in this sequence. So, 5 plus 6 plus 7 plus 8 plus 9, which is equal to 35. Therefore, the series of this sequence, 5, 6, 7, 8, 9, is 35. Another example is 2, 4, 8, 16, 32. To get the series of the given sequence, you just add all the terms in the sequence. So, 2 plus 4 plus 8 plus 16 plus 32, which is equal to 62. Therefore, the series of the given is 62. At this time, we will be solving problems about patterns and sequence. Find the first 5 terms of the sequence whose n term is a sub n is equal to 7n minus 5. To solve this problem, we have to think about what the values of n are. Look at the given problem. We need to find the first 5 terms. This means to say that we will use the numbers 1, 2, 3, 4, and 5, and that numbers are the domain of the sequence. Now, by substituting the values in the given expressions, we'll give the following terms. We have a sub 1 or the first term. Substitute 1 since this is the first term. We have 7 times 1 minus 5 is equal to 2. Then, second term, 7 times 2 minus 5, which is equal to 9. And keep doing this until we have the fifth term. So, the first 5 terms of the sequence are 2, 9, 16, 23, and 30. Using this nth term or the general term for this sequence. Another example, find the 8th term of the sequence whose nth term is a sub n is equal to n plus n over 2. Since we are looking for the 8th term only, we will be substituting 8 to our n or automatically use 8 as the value of n since we are to find only the 8th term. So, by substituting 8 in our expression, we have the 8th term which is equal to 8 plus 8 over 2, then simplifying 8 over 2, we have 4. Then adding 8 and 4, we got 12. Therefore, the 8th term is 12. And that's it. I hope you enjoyed today's lesson and learned a lot today. This has been Teacher Jo for ClickGen.